Welcome to section 2.3, sine and cosine functions. At the end of this section, you should be able to answer all these questions. What is a periodic function? What is the period of a function? What exactly is sine theta? And what is cosine theta? What is the UV coordinate system that we'll be using in our textbook? Why is r always positive? What implications are there if r is always positive? What is a parent function? What are critical points? And how do critical points assist us in sketching transformations? Alright, so let's talk about periodic functions. Here's this definition. The function f is a periodic function of x if and only if there is a number p for which f of x minus p equals f of x for all values of x in the domain. What that basically says is that our function repeats itself over a certain measurable distance. That smallest measurable distance that causes repetition is what we call the period of the function. Sine and cosine functions can be measured for any angle, not just the angles in a right triangle. So we're going to let UV be a point r units away from the origin on the terminal side of a rotating ray. So let's take a ray. We'll put it out here, and we're going to label that point where it ends u comma v, which means that we are u units horizontally and v units vertically. Giving us a distance r for this angle theta, r units away from the origin. So if we are going to calculate the sine of theta, that angle that we've drawn here, it would be defined by the vertical distance over r, and the cosine would be the horizontal distance away from the origin over r. If we rotate r around the origin, you can see that our horizontal distance and our vertical distance will change even if r remains constant. If we track that, we'll see graphs that are created that look like this. If you click on each of these graphs, you can see them being created on a website that I found. If you really want your mind blown, click on the fancy. To see how the sine wave is generated, we're going to take our ray r and rotate it around the circle and see what happens to the vertical distance from the horizontal axis. As you can see, it grows until it reaches a maximum, then shrinks until it's back on the horizontal axis, so a vertical distance of 0, and then it becomes negative as we continue our trip around the circle. Now let's look how the cosine wave is generated by measuring the horizontal distance for our reference triangle as we rotate r around the circle. As you can see, it starts at a maximum, hits 0, becomes negative, goes back to 0, and then finally returns to its maximum.